Hello, hello, hello. Today we are talking about angles of elevation and depression. So it's still using SOHCAHTOA, but more with real life types of situations. First, what is an angle of elevation and depression? An angle of elevation would be if you were looking straight and then you looked up. Elevation means you're looking up. So in this picture, you always have a horizontal line. That would be like if you are the person at A, and this is you looking straight, and then you looked up, this would be your angle of elevation. Angle of depression is just the opposite. So if you were up in the sky or on a cliff, and you were looking straight, and then you looked down, this would be your angle of depression. And as you can see, when we're talking about angle of elevation, you can always draw a right triangle. When you draw a right triangle, this is typically what it will look like. An angle of depression, this is what your right triangle would look like, and that's where your angle of depression would be. So if I'm to be this hawk right here, or this bird, and the bird's looking straight, the dotted line is where it's looking straight and then it looks down. Is that angle of depression or elevation? Well, since I'm looking down, that means it would be a depression, and this is what my right triangle would look like if I were to set up a picture for a problem. If I were a hot air balloon, and if I were looking straight, and then I looked up, oh my gosh, there's a bird. That would be an angle of elevation because you're looking up. And again, this is what your triangle would look like. So I want you to pause the video right now, and I want you to see if you can know 3 and 4. Angle 3 would be an angle of depression. So if you were in the hot air balloon and you looked down and you said, oh my gosh, there's a little ant down there. Or if you were the ant on the ground for angle 4 and you looked up and you said, oh my gosh, there's a person up there. Looking up, elevation. Looking down, depression. So I have this word problem now. You cite a rock climber on a cliff at a 32 angle of elevation. So before I do anything else, I'm going to draw a picture. Angle of elevation would look something like this. So this right here is my angle of elevation because this would be looking straight and then looking up. And it's saying the angle of elevation is 32 degrees. So you should always, always, always draw a picture of these problems. Your eye level is 6 feet above the ground. So if this is you standing here, this is saying that from your eyes to your feet is 6 feet. And you are 1,000 feet from the base of the cliff. So if this is the cliff, this is where the cliff is at. Cliff, cliff, cliff. This is 1,000 feet. What is the approximate height the climber is from the ground? It's asking basically, what is the height of the cliff? And actually in my picture, I should draw this cliff a little bit further because it doesn't start in mid-air. So I'm asking, what is x? So in this problem, you still have to use SOHCAHTOA. So in this picture, here's my angle. I'm looking for my opposite, and I have my adjacent. So I know I'm going to be using TOA. So I have TOA. It's going to be tan of my angle, so that's 32, is equal to my opposite over my adjacent. You have to be careful though, this opposite stands for this x, right there. So when I cross multiply, I have 1,000 times tan of 32 is equal to x. That's going to be, if I round it to 625 feet. That's this x here. So I'm asking for the total cliff, so I still have to add on this part. But if you remember, this part is the same thing as this part. So I have to add on 6 because that's how tall I started from my eyesight. So my total would actually be 631 feet is how high the cliff is, or how high the climber is on top of the cliff. Angle of depression. Again, to approach the runway, a pilot must begin a 3-degree descent starting from the height of 2,700 feet. What does this mean? Well, first, it's an angle of depression, so I'm going to draw my triangle out. Why did I draw it differently? Because this is my angle of depression, because this would be if I were looking straight and then looking down. So this right here would be 3 degrees. And it's saying a height of 2,700. So height would be, if I were up and down, so this would be 2,700 feet. To the nearest foot, how far from the runway is the airplane at the start of the approach? So this is where you have to be very careful labeling what are you looking at. So this is your airplane right here, and excuse my airplane, it's not going to be the best. It's asking, here's the runway. How far away is the airplane from the runway? So I'm looking for this X. So now that I have my picture, I can decide, is it so, ka, or toa? So here's my angle. I have my opposite, and I'm looking for hypotenuse. So O and H would be so. So it'd be sine of my angle is equal to my opposite over my hypotenuse. Once you have your proportion, then you cross multiply. So x times sine of 3 is equal to 2,700. I have to divide by sine of 3 on both sides of the equation. So x is going to be equal to 51,000, whoopsies, 590 feet, because my units were in feet. So that would be my final answer. So again, word problems is just drawing the picture first and then solving so, ka, toa like we have been in class. So make sure that you took good notes and have a great day.